Welcome to this next video in the Arduino C++ series, and today we're going to be looking at the IBT2 BST7960 Motor Driver board. And this is a big motor driver board. This is a 43 amp one, so you can drive some pretty hefty items off this board. Now, going over to the workbench, obviously I've got the one board set up that we're going to be using. I've got another one here that I've put next to the L298N, which is the motor driver board that you tend to get in your Arduino starter kits. Now, this board has a maximum capacity of 2 amps. Obviously that is a fraction of the 43 amps that this can put out. Obviously this has quite a big sort of heat sink on it. When it comes to this board, the whole underside is a heat sink. So this board is going to be handling a lot more power. It's a little bit more efficient than this board. And today we're going to be looking at how to use it. Now, one big difference between the two boards, the L298N is able to drive 2 motors at a time. The IBT2 can only drive a single motor. Now, as always, I've done a resource page, so if you click on the link below the video, that will take you over to the Digital Town site. And if you have a moment, please click the like and subscribe, because it really does help the channel. Now, going over to the resource page, obviously we've got the video. I've got some information about the board, and there are some important things to know about this board. It will handle 5.5 to 27 volts. Now, one thing to be aware of, if you drop below the 5.5 volts, the board will automatically shut down, in the same way that if you go over 27 volts, it's also going to shut down. Now, because of the way that voltage slightly fluctuates, realistically, I would tend to stick between sort of 6 and 24 volts for your projects. Now, it says it's got a maximum output of 43 amps. If you're going to be drawing that much power for a prolonged period of time, you're probably going to need a fan blowing over that heatsink. One other thing to be aware of as well is that you are going to need to make sure that the wiring to the motor driver board and to your motor is capable of handling 43 amps. That's a lot of power, and you need to make sure that you're not going to start setting fire to your wiring. Now, the logic pins, so there's 2 sets of pins. Obviously we've got the power for the motor. We've also got the power that drives, if you like, the circuitry, and that's a 3.3 to 5 volt system. So you can use an ESP32 or an Arduino 5 volt board, depending what your choice is. However, as we will see later, there are some issues with these boards. Now, the board has what is called current sense, and this means that we can actually work out how much current the motor is drawing from the board. This is a very, very useful function, but it does have some issues with our microprocessor boards. You need to be very, very careful that the output voltage for this function doesn't exceed the ability of the boards. As always, there's some built-in protections for this. There's temperature, voltage, lockout, over voltage, under voltage, overcurrent, and short circuit. But again, overcurrent and short circuit, just be aware, when you've got a board that can handle 43 amps, if you have an overcurrent on something that is able to handle less than 43 amps, if you don't use the current sense facility, by the time you find out, you may have melted your component. So just something to be aware of when starting to use these very powerful boards. Now, I've also put the pinout, and the pins, there are 2 sets. You've got the header pins. These are, if you like, for the logic side, the 3.3 to 5 volt part of the board. And then you've got the motor driver section on the other side. So we start off with the pins here. We've got an R PWM and an L PWM. Now this tends to be listed as the forward direction and the reverse direction. To be honest, that just depends how your project is set up. So for that, you send it high, send the motor at full speed, or we can send a PWM signal to reduce the speed. We've then got a forward and a reverse enable pin. So this pin needs to be high for the high or the PWM signal to have any effect. We've then got a forwards and reverse current sensing pins. This gives off a voltage in proportion to the number of amps that is being drawn from the board. And finally, we have a VCC and ground. Now, as I've said, it's a 3.3 to 5 volts, so you can use this with your Arduino or your ESP32. Now, here we have the power supply for the motor. Now, the way the circuitry works, this is completely separated from our logic, which is a good thing when we're putting out that much power. Looking under the board, just one thing to be aware of. I find this a little bit illogically. I would have thought that this would be the power supply for the motor, ground, power supply positive. You would then expect the motor output to be negative and then positive, but it isn't. So just be careful when you wire this up and make sure that your power supply going in is going to the B plus and B minus, and M plus, M minus is going to your motor. Now, as always, I've supplied a circuit diagram of exactly how I've set up my board. Finally, moving down, obviously there is the link for the code, and there is also a link for a video I did on the L298N motor driver board. And the reason I've put the link to that one is that also shows how to use PWM to control the speed of the motor. Now, looking at the circuit diagram, over here we have a line that is going to pins 9 and 10. These are giving a high or low or the PWM signal, depending how we want to drive the motor. I've then connected the enable pins for both directions, because it just means that you can get away with using one pin and there's no problem in enabling both of them together. You will also see that these two connections for the current sense, I also have them connected to the same analog pin on the Arduino, and that is quite important with this board. One of the problems with this board is that as the amps increases, the volts that are produced by this for the analog read is 1.176 volts per amp. Now think that through. When you get to 43 amps, and you're suddenly going to be a lot more than the 5 volts that the Uno can handle, and by then your ESP32 is smoking. So by connecting these together, it changes that output, as we'll see in a bit, allowing you to use this board for slightly higher ampages. But if you're going to be measuring the ampage directly, there is a limit to what you can do with the board. Finally, we've got the ground and the VCC. The VCC can be 5 volts or 3.3, depending if you're on a 5 volt board or a 3.3 volt board. So that is the circuitry, and then we've got obviously the motor supply, 5.5 to 27 volts, and the motor connected to it. Now, just to give you an idea how powerful the motors are that you can drive with this, these motors that are this board, the IBT2, or at least the BST7960 that is used on these boards, that is used within cars to drive things like your electric windows, your sunroof, your motorized seats. It's also used in some e-bikes and e-scooters. So as you can tell from that, those are some pretty hefty motors, far bigger than the little motor that I'm going to be testing it with today. Now, going back to the photo of the board, one of the things just to check on your board is that your board is actually a 7960. There are some other chips that are very similar, and there are similar boards to this that use these other chips. The reason it is important is that will tell you how many volts per amp are on the current sense. Some of the other boards have different resistors on here, and so the if you like, the number of volts per amps is different. I must admit, some of the newer boards have smaller resistors, and I actually think they're an improvement because you can measure far higher currents. But this is the board that I'm going to be using because it's what I want for a particular project that I'm working on. So going back over to the breadboard, as you can see, I've got a DC motor. This one has a stall current of around 1 amp, as you'll see later. I'll be honest, this is just some motor that I dragged out of, I think possibly a scanner or a printer. I have been abusing it. I've run it up to 27 volts. I'm pretty sure it's not supposed to do that. As I've been testing this board, it is a motor that has no value to me, so I have abused it and will abuse it in the video, as you will see. And it's always worth collecting old motors out of different items for your Arduino projects, as they can be quite useful for testing things like this. So now we've got all the intro stuff over, let's get on with the code. Now, for this first sketch, I am going to be using 2 current sense pins. Now, in the video, in the circuit diagram on the site, I've connected both pins together, and they will be connected in the later sketches, but I'm just going to show you why I've connected them together and the impact that has. So we're going to have them separately first. So to keep the sketch simple, I've got the enable pin, if you like, that's the turn the thing on or off. I've got the reverse PWM pin and the forward, and then I'm starting the serial monitor. And this line of code here, a little bit of code I found recently that actually prints the file name and its path, the date and the time to the serial monitor, which is very, very useful for finding where you stored the sketch on your computer. I've then got the pin modes, the enable and the PWM pins are all being set as outputs. And then I'm just going to start this sketch in the setup. I'm just going to set the enable pin high. That will allow me to send the motor in either direction. And then I'm going to start off by setting the R PWM pin high, and then we'll set the L PWM pin high. So let's just run this sketch. So as you can see, I've got my motor racing away, and if we change this particular line of code and upload the sketch, we will see that the motor now turns in the opposite direction. Now, at the moment, I'm just sending the pins high, so it's going flat out. I'm now going to comment both of these out, and we're going to do an analog write, and I'm going to set the value to 25. Now, the values are 0 to 255, so 25 is about 10%. So let's upload that and see the impact that it has. So as you can see, now that the sketch is uploaded, the motor is now turning much, much slower, and it's actually much easier to see the direction that it's moving in. So now we've seen how to set the direction, and also by using the analog write, we can set the speed. We're now going to come down to the main loop. because in the main loop I'm going to be doing an analog read on pin A0 and pin A1, and this is the current sense pins. We're going to bring up the monitor. Now, as you can see, the values are virtually zero because it's not drawing much power. So I'm going to set the motor to flat out. And as you can see now, I've got some larger values. Let's just stop that. And you can see I've got a very low value in one direction, a higher value in the other direction. I'm going to let that scroll. And what I'm going to do now is grab the motor, burn my fingers. And if you look, you can see that that value on the right-hand side is going up, as well as slightly on the left-hand side. So grabbing the motor in this direction, you can see that the main increase is in the right-hand value, which is pin A1. If I then change the direction of the motor, let's just change this. Now when I grab the motor, you can see that it is the first value that drastically increases, and that is the A0 current sense pin. Now, one of the things about this, if I just grab the motor again, let's just stop that, and I'm just going to turn the system off. If we now look at the serial monitor, all we're getting for the value is values sort of 180, 174, 82. These are not actually showing the voltage that is coming out. This is showing a value between 0 and 1023, which is the reading from the analog read. What we now need to do is, if you like, translate that into actual voltages so that we can work out how many amps this motor is pulling. So in Sketch 2, I'm going to start off with exactly the same circuit as the last one. I've still got the same pins, and this time I've introduced current millis, timer millis, and a timer. This is going to check the readings every 0.1 of a second, just so that I don't overload the serial monitor. I'm going to be running the motor clockwise in my case. Again, it's one of these things, forward or reverse, depending which way you put your motor wired in. It's really up to your project. Coming down to the main loop, I've got a couple of variables for my voltage and my amps. You'll notice they are floats. That's because I want values after the decimal point. I'm then going to use current millis to get the time of the board in millis, and we're going to be running that timer every 0.1 of a second. And every 0.1 of a second, it's going to do an analog read. Now I'm going to start off on the AO, and then we shall go to A1, but obviously that is in the opposite direction. We then need to work out the voltage. Now the voltage, we map the values that we receive from the analog read. Analog read on the Arduino Uno is going to give a value of 0 for 0 volts up to 1023, which is 5 volts. I'm then going to map that using the map function here, and that is going to give me the equivalent value between 0 and 500. For my voltage, I'm then just going to multiply my voltage divided by 100 multiplied by 1.000. This way it forces the float value to 3 decimal points, and then I can work out my amps by dividing my voltage by 1.176. That's because the spec for this board says that for every 1.176 volts produced, 1 amp is being drawn. I'm then going to serial print out my analog value, my voltage, and my amps. Now you'll notice I've put a 3 in here after the serial print. If you don't put anything in, then it will print out to 2 decimal places, but I want to print to 3 decimal places, hence the reason for putting this value in. So the motor is now happily spinning away, and what I'm now going to do is I'm going to grab that motor again and try and stop it. Now you can see when I stop it, it's giving a value, what's that? It's about just over 1 amp. So I've turned the motor off so that we can look at the serial monitor without it flicking by at speed. And we can now see the values in voltage and in amps. So a value of 290, which is the analog read, gives a value of, where are we, 1.41, which means it's drawing 1.199 amps. Now, great as it is to get the correct figures out, it also shows a bit of a problem. Because if we're looking here at 1.4 volts equals 1.190 amps, as the amps increase, the voltage is going to go up dramatically. Now, this is supposedly a 43 amp board. Well, the problem you're going to have with your Arduino is by the time I get to 5 amps, which is what I actually need for my next project, I will be getting 5.88 volts. At that point, I will have overloaded the analog pin on my Arduino, and there's a good chance that I will damage that board forever. This becomes an even bigger problem if you're using a 3.3 volt board, because you will reach 3.3 volts at about 2.8 amps or something like that. So if you're going to be wanting to measure the number of amps that this board is producing, then you're going to either have to add in some extra resistors to reduce this value or find out some other way of measuring the current. That's why on some of the later boards, I think it's the 7970 or something like that, they have a different set of resistors in there so that the values are much lower. The voltage is much lower, so that you can read to much higher amperages on the board. Just something to be aware of for your project if you're looking at using high amperages. Now, going back to the circuit diagram, as I've said before, I am connecting both of these analog pins together for the output. Now, the reason is that these have a 10k resistor. If I connect the 2 of them together, because the resistors, the way they're set up, that means they're going to be working as the equivalent of a 5k resistor, which means that I halve the voltage for the same number of amps drawn. So I've made a quick change to the circuit over here. So instead of having the individual pins coming over, now both pins are being read off A0. So both pins being read at exactly the same time. And there's not a problem there, because only one of them really matters, because one's going in, one is for one direction, one is for the other direction. Now, just so that we can prove that this is working, you'll notice that when I stopped the motor, it gave a voltage of around this sort of 1.37, 1.165. That is the stall current of the motor. Now, it's not great to be stalling your motor, but as that motor is of no value to me at all, I don't mind if it gets damaged in the process of making this video. What I'm now going to do is, as I've now connected both the analog pins together, I'm going to run the sketch again And now we're going to take a look at the outputs when I connect both the analog pins together. So now we've got the readings going, and it's very difficult to tell any difference when the motor is just spinning freely. However, now when I grab the motor and stop it, you can see, let's just turn that off. If we now look at the output, you can see that rather than having that 1.1, I am now at 0.527, and the same, I've got my voltage drop there as well. So now what we're seeing is approximately half the voltage and obviously half the amps, because I've connected those two together. So all we need to do is make a slight change to the calculations. So if I comment this out and uncomment this line, now instead of multiplying by 1, I'm going to multiply by 2 to get back to my original figures. So now if you look at the serial monitor, you can see the values have increased slightly, and the big test is when I stall the motor, and you can see that my stall current is about the same as it was when I was monitoring the 1 pin. Now it didn't come out quite exact, and I actually discovered that if I did a little bit of messing around, I could get it absolutely exact, and instead of 2, it's 1.948. This is due to some issues, I think they call it voltage leak or something like that. But as you can see, in general, multiplying by 2 is going to get you a figure that is pretty close, probably accurate enough for most projects that you're going to be doing. Now, the advantage of the voltage being divided by 2 is it means that for your ESP32 projects, you can measure up to 5.6 amps and still be within your 3.3 volts. And for the Arduino, you can now go up to 8.5 amps before you get to your 5 volts. So you can now have a greater range of ampage that you can now measure with your board. Now for the final sketch, sketch 3, we're going to start to look at why that current sense is important. Now if we go back to the webcam, my little motor here, I can stall it by when it's giving about 1 amp. Now the power supply that I'm using will put out 8.5 amps at 5 volts. So if I continued to lock this motor up, eventually this motor is going to cook itself. So by using the current sense, we can actually start to work out if our motor has a problem. Now a good example of this, you can try this at home, be careful, is if you go out to your car and you've got power windows, if you wind the windows up, if something is blocking the power window, if it's a good power window, it will sense the object and the window will wind back down. The idea is to not chop people's hands or heads off if they've left them stuck outside the window. Now the way that works is that there is the current sense that is sensing the increase in the power requirement as the motor starts to stall, and instead of continuing to try and wind the window up, it immediately goes, whoa, this is too much. I'm now going to put the window in the opposite direction and wind it down. So in this sketch, what I'm going to do is shut the motor down if it draws too much power. So this is the equivalent of what would happen in a machine if something broke, power windows if something's blocking the window, anything that causes an overload situation. Now the whole sketch is identical apart from this little bit in the main loop, and all I'm doing is if my amps is greater than 0.9, now my stall current was just over 1 amp, so I want to be shutting the motor down before it sort of starts to wreck itself. And all I'm going to do at that point is I'm going to set the enable pin low and serial print out overload. So let's get that uploaded. So we can see the motor spinning away. We've got the values increasing. If I start to touch the motor, we can see the power requirements going up. I've released it again. Now I'm going to grab it hard, and you'll notice all of a sudden, for me, the motor, I can just spin it as I want because it's been shut down. If I start to scroll back up, we can see that as I grab the motor, we can see the power requirements going up. We can see it's going up from sort of 0.068, 0.1, 0.3, 0.5, 0.7, 0.85, and then all of a sudden it got to 0.901, and at that point the overload code triggered, and at that point it shut the motor down. It turned off the enable pin. So at that point, it doesn't matter what PWM or direction signal I send, the motor will not move. So this motor driver board, it is a very, very good board. Unfortunately, because of the way that it works, the number of volts per amp, it's a little bit limited in my view. But certainly if you've got projects up to 5 amps, with an Arduino or an ESP32, you're going to be fine. And as I said, on the Arduino Uno with a 5-volt board, you can get up to about 8.5 amps using the current sense before you get to your 5-volt limit of your board. So a very, very useful board for the smaller projects. From a current sense point of view, though, certainly no good with an Arduino or the ESP32 if you want to start getting up into the 20, 30, 40 amp mode. So I hope that's been useful to you. These boards are available. I can get them from AliExpress for about £4. I can get them from Amazon for about £8 something. So depending where you get them depends on the price, but a reasonably cheap board if you're looking for the lower ampage usage, certainly below the 8 amps for the Uno. As I've said, it will drive more powerful boards, but if you then need to measure the amps, you're going to either have to add in some extra resistors to alter the current sense ability, or possibly try and get one of the, I think it's the 7970 boards instead. Anyway, thanks for watching. Hope that's been useful, and if it has, please click the like and subscribe because it really does help the channel. Thanks again for watching, and I'll see you in the next video. Bye for now.